Checking, check, check, check. Microphone 1, 2. All right. Hey, everyone. It's me, Ray Long. This is another episode of Full Stack Distributed Systems. Yes, it's nighttime once again here in LA, out at the Wizard Tower near LA Live, downtown LA. And we're going to come at you again with another episode. Now, we've been spending a lot of time working on Unity 3D. And we're still going to be working in Unity today, but not so much Unity. More like C# Visual Studio. We're going to continue with the C# adventure today, except today we're going to build a brand new feature in our game engine, and it's going to be a very, very powerful differentiator. We're going to start building it today. What is that exactly? A topology and weight evolving artificial neural network. Yep, that's a lot to take in. Let's break it down piece by piece. Topology. That means the way it's all mapped out, right? The logical layout of all the pieces and the physical layout of all the nodes. There's a physical topology, which is the way each node in the neural network is connected. I know we're getting a little ahead of ourselves here. And there's a logical topology, which describes the flow of information through each system and subsystem, etc., etc., etc. Weight evolving. What does this mean? Well, we're going to build a neural network. Neural networks have synapses. Synapses, in our case, are going to be weighted. Now, what this means is the weights on these synapses in our artificial neural network and our fake brain and our digital brain that we're going to create here, success is rewarded and failure is punished, more or less. And the mechanism by which it exerts, by which influence waxes and wanes, is by the weighted synapse, right? So obviously if the synapse is weighted, it's going to carry more weight leaning towards the it being used in the fitness function. I know we're getting way ahead of ourselves, but basically we're going to start building an artificial neural network inside of our game engine. We're going to be very good engineers, and we're going to keep that code completely separate and abstracted away from, not just abstracted away, that's the wrong word, but we're going to keep it completely discrete and separate away from what we already have, right? And we're going to try to, the best we can, we're going to try to keep our code clean, our modules discrete, and everything else like that. And we're going to try to use interfaces as the boundary between systems and subsystems. Okay? So, without any further ado, let's get right into it. Okay. Let's get into Visual Studio. Alright, here we are. We have our project. Let's go ahead and expand this out. Our Universal Wargame engine. Now what we can do is we can make a new folder under Assets next to Universal Wargame engine, or we can make this its own it's like its own package. I think we should probably set this up to be its own package in the future, right? Because essentially the artificial neural network doesn't have any overlapping concerns with the Wargame engine. They're completely different concerns. They're completely different scopes, right? So we'll come in here and we're going to add a folder. What are we going to call this? We're going to call this oh yeah, we could call this this? Tween. We'll call it that for now. Why not? Alright, so now let's go back into our webcam here for a second. Okay, so I don't want to make this unnecessarily complicated, because here's the truth in my opinion. Machine learning is very, very powerful, and presently it has a bit of an esoteric, mystical haze around it, where it seems pretty impenetrable, and there's a lot of mysterious stuff going on, if for no other reason than the simple fact that these neural networks are performing calculations faster than any human mind can hope to, you know, keep in its head, right? Like, the domain, like the problem domain that the AI can keep in memory is a lot larger than what I can consciously, you know? It can keep millions of objects in mind. I can keep 5 in mind. That's why we keep building up higher and higher levels of abstraction, right? So we can still keep a few things in mind, but the few things that we're concentrating on have so much power down the rest of the system. And conversely, if we have a really narrow focus on a small, tiny subcomponent, you know, we can isolate that unit, and, you know, apply it, have it be discretely changed throughout the system. Anyways, basically, we want to keep our code clean, and that's going to be a bit challenging. But we are going to succeed. All right, so I've been babbling enough. All right, so what's the first thing we're going to need in our neuroevolution library? Well, let's see. We're going to need okay. Let's make a species first, okay? We're gonna add a script to Visual Studio. You guys probably don't see all the dialogues that pop up. No, you don't. So we're just gonna, for now, we'll just make this an empty class. We're gonna call it species.cs. We can always reorganize our code later. And you know what? We're not gonna assume that this needs to be a game object. Okay. Call this, I want to see how we named our other stuff. Yeah, this is what we want to do. Let's take this. I mean, assets is fine, but doesn't really tell us enough. We don't want universal Wargame engine. We want, we can do, Tween. 3D is fine. It's fine. Okay. Okay. So, what are we going to need in here? So what we're going to need. We're going to do some threading in here. I'm just going to hack for a while, and you guys, we could just hang out, and I'll chime in once in a while, you know. What I need are these, okay, good. So, when you're going to need some delegates, I just want to check my delegate syntax. Alright, make this public. Public delegate, I imagine we're going to have a void. Let me think. Yeah. So this is actually going to be our on improvement delegate. We want to have our species be the sender. And we want... We're going to need an IMutation interface. Make a mutation type. And what's a mutation? Well, mutation kind of falls under the purview of neuroevolution, in my opinion. So let's make a neuroevolution folder, and then let's make this interface. Now, I'll talk about this as we go on and keep building it, but I've already built a bunch of these before, and it's kind of hard, even though I understand what's going on, it's kind of hard for me to boil it down into layman's terms without compromising some technical detail at the moment. So, for now, we'll just do the best we can, and we'll keep talking about it as we get inspired. Oh, that's wrong. We don't need 3DS. That's stupid. Okay. Let's add new item here. I'll just call this IMutation. Make an interface called IMutation. Okay. Let's pin our species and our mutations. Make sure you guys are seeing everything here. Okay, very good. Let's go back. Yeah, we want this. Oh, my phone is about to... I got a weird, funky setup because I don't have any power outlets out here on the patio. I want this to be in the neuroevolution namespace, because why not? Great. So now we can use this over here. It knows about it, or at least it will. I forget the command. It should be. I forgot, but we can import this. There's a little light bulb here. I keep saying import. We can use this. All right, very good. So now we have that. Do we want the delegate on the... Yeah, we want it in the namespace. You know what? Maybe this one is good to keep in the species. Now, actually, we're going to move this up. There we go. We'll make it namespace level. Seems good. What are we going to need inside of our species? Well, should we take a look at the IMutation first? Let's take a look. Let's think about it. Let's think about it. What could we possibly need here? Well, we're probably going to need some kind of mutate method, I would imagine. And that's going to have to take a neural network of some kind, which we'll define shortly. Why is that? I can actually probably create this right in the IDE right here. Yeah. There we go. Fantastic. I love it. Okay. We need... If we can mutate. Now, the mutate is going to run and either it's going to be successful or unsuccessful. We could have mutate return a Boolean, But it's going to be easier to do what we want to do with this if we just return void for now. You know, that way we can just fire it off, and it should be fairly easy to fire off. And this is actually a pretty good candidate for something that we could actually put in like a game button, right, inside of a UI. So far we haven't done anything Unity specific except the way we've organized our physical source code over here in the project. We see there in the Solution Explorer. But so far we're not using any of the any Unity libraries or packages or namespaces libraries in the code that we're writing right now. So anyway, so we need to be able to call something. Call if mutation fails. What do we need? We're going to have to return a neural network of some kind. Call this rollback mutation. That works. So this is going to return the previous state. What if the mutation succeeds? Well, that's probably desired, right? So we can have, and we know. Oh yeah, well, okay. We don't want to, resist. Let me just tell you right now, resist the urge to make big, complicated interfaces, because then you're gonna destroy the incentive to use them if you have to implement every goddamn method of the interface. See, by the time you're done implementing an interface, you should feel confident that the thing works, and you should be able to understand what you're doing and why you're implementing each method. If you have more than a handful of methods, I mean, like 5 is probably the most that you'd ever really, ideally, probably want just for manageability. Like these 5 methods, I can keep them in my head and think about them. Well, what will be 5 methods? I got mutate, rollback, successful. Determine if can improve. So this is going to be a Boolean. We're just going to return a field from this. You know what? Let's make it easy. Just make it a property. Full property. And do the improvement. Void. Let's call it improve. So yeah, like I said, that's good guess. 5 methods. So our mutation, we're going to be able to call mutate. It's going to accept the neural network and it's going to mutate that somehow. Here's the thing. The mutation is definitely going to be occurring. Whatever neural network we pass into this method is going to be mutated. So we may want to refactor that later to make it a little more thread safe. It's alright, for now this will work. Back to our species. Alright, we have our species. Alright, we want to be able to define, this is going to be interesting. Let's do a neural network here. And a double. We like doubles. In neural network land, doubles, floats. We're actually going to call this the fitness func. That's right, we're getting funky with our fitness. And let's give it a get and a set. We're going to want a neural network on here. property. Oh my goodness, I can't type, ladies and gentlemen. Oh yeah, probably gonna give this a name. Ugh. Can you tell it's getting a bit late? What else do we need on here? Ugh. We're gonna need some way to store our mutations. So, a good way to do that is you probably have a dictionary with mutation as the key. The value that it... Okay. You'll call those mutations. Okay, what else do we need? We need a way to track our iterations.
Any ideas?
But only we want to be able to update that counter. You know what? Probably want to make this a private setter as well. Especially without a typo. Yeah. Such weird music. My weird do-it-yourself. Free for everyone to use music. But I like it though. It's interesting. At least to me it is. Hopefully you guys like it too. Alright. So, iterations. We need to know how many cycles we've run through with this particular species. We need our best fit. Okay? We'll get more into what the best fit is later. But basically this is used with our fitness function to determine some stuff. Like if it's the best fit or not. But how that actually gets implemented, we'll see that a little bit later. We need a sensitivity. Make this a double as well, so we can get some precision. Let's see, we'll call this sensitivity. Of course, sensitivity. We're going to use that. Use that field for various calibration purposes. Now we're going to need an event to handle that delegate up there. Call this event on improvement delegate. Do I need to get a... Is that valid? No. Okay. Yeah, I don't need to do that. Okay. Right. Okay. Cool. Let's go ahead and be good coders. Species improvement. Determine whether the species passes or fails its evolution. Ooh, that sounds brutal. Okay, so this is going to be the neural network used by this species. Here's what we can actually do. Check this out. So now let's take this. So that means now I can actually, like, in my documentation, can get more information about that from IntelliJ. Fantastic, isn't it? Programming is great, ladies and gentlemen. Love it. All right. Now, we're going to be doing a lot with IMutation. We want the interface. Everything that comes in here, though, is going to be an implementation of the interface. And so anything that implements this interface is fair game. That's it. Doesn't matter. Collection of mutations for the species. Now, since the IMutation is the key, that means we can't have duplicate mutations. We can have any combination of mutations we can think of, but we're not going to have duplicate instances of the same mutation on the same species. That would just be too bananas. Alright. Counter to meter the evolutionary iterations of the species. Okay. Used to determine success or failure of an evolution. Calibrate the sensitivity of our species. Get added to do to this. Clarify this documentation. Clarify the above. Let's see. Clarify the meaning of calibrate and sensitivity. Alright, that's fine. Excuse me. Okay. Oh my goodness. We're going to need a random number generator, and I just realized that. Well, I didn't realize that, but I've been thinking about it, and I have to decide if we're going to use the seedable random number generator that we used for our dice roller, or if we're going to do something else. It's a very good question. I think you can pass in a seed to random, though. But the Unity one, and this is ideal. Well, here's the thing, right? We are building a Unity package, so let's go ahead and use the Unity one. You see that? It was fair. It was easy enough. I forgot how to use it, though. Let's see. Okay, let's see. Seed. Let's see, what do we have here? Let's pick a different one for this. Okay, there we go. Fire this event. If it has listeners. Successful improvement. Okay. Seed for the pseudo RNG. Let me see again how I did the dice roller. Okay. Uh, you know what? Is this a static? Control. Hmm. Can I not get an instance of this? Okay, so you know what? We're not going to worry about a seed here. No. Okay. Let's see. Let's see. I think this will work. So actually we do want see probably gonna have a few different constructors on here. Okay. How's the video? Okay, video's going great. Seed for our local pseudo RNG. You know what that means? Dice roller. Dice roller. Need to add it to do here. Replace static. Unity engine. Oh. Random.range call with instance of Unity engine dot random. So we'll probably need to test to make sure that it's actually possible, but we'll write it for now. Seedable pseudo RNG used during go. Okay. Alright. So let's, this is not going to be a game engine, so, or excuse me, a game object type. So why don't we're going to make a constructor. What are we going to need? Well, we're going to need, I wish I had a type alias. We need a neural network, a double. We're going to need to build our, let's call it, I think we want to call that a fitness func. Fitness func, yeah, okay, neural network. Network, we need to pass that in. Who boy? What else are we going to pass in? Oh yeah, probably some mutations. Otherwise, we're not going to be able to do anything useful. Yes. Oh my god. What am I even typing right now? Oh. Already. Okay. Just sign the fitness function. Come on, man. Whew. Okay. What else we need to do? We need to assign our network from the constructor. We're gonna. Did we already? No, our mutation is not. Okay. So mutations equals new. Let's make the dictionary for now, because we can't. We don't want it to be null. Okay. So if mutations not equal to null, what else? Oh, we need to have mutations.count is greater than 0. What are we going to do? I'll tell you what we're going to do. We're going to populate this dictionary. For each var no in mutations. So we're going to spin through these as we say. We're going to say mutations dot add m dot key m dot value, right? Yeah. And then our best fit is actually going to be from the fitness func. All right. We got to know what that best fit is. Probably should add some documentation to this. Oh yeah. Let's see, neural network and a doble. Okay. Wow, my typing is awesome. And know what? Okay. Important to have documentation. Pretty good. Uh, an object capable of undergoing evolutionary improvement. That's not it. The type. There we go. All right. Okay. Let's see. Let's check a look at our. There's probably going to be some instances where actually, now that I'm thinking about it, we probably don't actually want to pass in any mutations. Actually, can think of a few reasons why, and we'll get to those later. So we're gonna need another constructor here. Let's just take this. We don't want to type it all out again. That'd be ridiculous. Now let's get rid of the mutations. We don't need those. Okay. There we go. Just a smaller constructor. Let's grab this description. Why would I want to write it again? Good. We actually need to do we need a unit of work for the actual iteration itself. So, this is where we're going to start using our pseudo-random number generator. That's why it's important that we're able to have a seed on it, because essentially this means by having a seed, we should be able to possibly create the same pathways through a solution. In other words, we might be able to get predictable results with our evolutionary algorithms. But we also want useful, unpredictable results as well, right? It's definitely like multiple things we want to accomplish. Alright. So the first thing we're going to do is we're going to spin through all of these mutations. Let's call it mutation. Let's be explicit. And mutations. Okay. We probably need to add some diagnostics here sooner than later, but we don't really have much to do in our iteration method, really, honestly. So that's what we need to do. If we have an RNG, okay. G. What? We. I guess we're not actually going to be able to. Fuck. Damn. Okay. Trying to think. Think here. Wish I knew more about. Oh. So really, I mean, this is kind of a funky ass class because look, we got to be careful with how we use this round number generator. And we might not always be using the seeded value that we think we're using, right? If I wanted to make this really safe, what I have to do is I have to get the internal state, right, run my sequence, and then return it to its previous state. Holy shit. I'm going to have to do some research on how people are effectively using multiple seedable RNGs in their Unity projects. We're not going to worry about it for now, but, you know, greatest thing. Okay, so we're actually gonna do something a little bit different. In our species, I know we've had doubles. Just realized that floats are gonna be easier in terms of like less typing that I'm gonna have to do to convert back and forth between floats and doubles. I'm like, just why not just use floats? You know, makes more sense. Oh man. There, now we don't have to do anything extra or special. Dot random dot range dot random dot is there not a oh god oh yeah, that's what we want to do. Let's just set the value. It's less than the mutation dot value. Think about how we want this to work. Okay, so basically here's why we need the sensitivity, okay? So, if mutation type is a neuron, we're going to add a new neuron. Only add if here's the question. We want it to be I'm not really sure how. If not sensitivity threshold. This next bit of code is going to be a little funky. We're going to need a new class. We're going to call this a connect neuron. Where should it live though? Yeah, in neuroevolution. We'll call this a connect neuron. Namespace is IMutation. Kind of annoying. I should make a new template in Visual Studio, but I'm too lazy right now. Not lazy, but it's just not the highest priority. Okay, now we have a connect neuron, right? So now we're going to say if the mutation dot key is connect neuron. Okay. Let's do a oh, I forgot something, guys. We need to mutate the network. And we need to make a mutation fit. Okay. Now this is going to be mutation fit minus the best fit. Here we go. If that's less than the sensitivity. Or, let's do this, or mutation fit is greater than the sensitivity, right? Or greater than the best fit, right? Yes. So it's not actually that hard to okay. Okay, so this is called a ternary expression, okay? This is ternary means 3, and this is actually 3 pieces of logic in one expression, okay? This is not that intimidating or that scary. It's actually pretty easy to think about. That's why I've rewritten it this way. So let's walk through this ternary expression, which is new here on new for our videos here on full stack distributed systems. All right, so if mutation.key, if it's a connect neuron, okay, if that's true, we're going to follow the question mark path, which is, okay, so basically this says, if mutation.key is a connect neuron, then I want to know the answer to the question of what is, is the mutation fit minus the best fit, is that total? Is that greater than the sensitivity threshold? Okay, but if it's not a connect neuron, if mutation.key is not connect neuron, then I want to know if the mutation fit is greater than the best fit. Right? So we only care about sensitivity if it's a connect neuron. Otherwise, we're checking just the best fit. Okay? Okay. So now we're going to say best fit equals mutation fit. Now, while mutation dot key dot can improve. Okay, while this is true, because improvement's not always going to be possible, but while it is, let's call it mutation dot key dot improve. Then we're going to say mutation fit. Now we have a new mutation fit because we've improved it. So we need to recalculate our fitness function with our network. Now we're going to use the hyperbolic tangent for our fitness function, but I promise you it's not as scary as it sounds. Okay? And we're almost done making our species. And then that's probably what will be the end for this video. Yeah, definitely. Alright, so we need to update our iterations. So now we say if the mutation fit is greater than the best fit, we have some other things we need to do. Namely, we need to update the best fit with the mutation fit, because now that's the new score, right? That's the new threshold that we're going to have to, it's our new barrier to improvement, right? Otherwise, mutation.key, rollback mutation. Okay, so after this while, that's when we want to call our event if we have listeners. So, if on improvement is not equal to null, because remember we're using an older version of Unity. We don't have the .NET Core framework yet. We're going to call on improvement .invoke with this and mutation.key. Fantastic. So now after now we're going to say here, otherwise we're going to need to roll this back, right? Let's this is the right. So, see, we're going to have to do some refactoring to clean this up. Let's iterate right here if we need to, which we do. Right. Yeah. Uh-oh. Yeah, we don't want this to be in the for each. You know what, we can actually... Oh, this is fine. Yeah, this should be it. So... I always forget how to do this. Format the code. Oh, this should be fine. Alright, so we have, this is basically how you build a species for topology and weight evolving artificial. Let's check the time. We're a little over an hour, so let's talk about this and we'll finish it up, and then we'll get this out there, okay? So we've started our new package. This is going to be our tween 3D art topology weight evolving artificial neural network. We've got an on improvement delegate. network, so we're going to have on improvement events. So we have a species. We can have discrete species with different fitness functions. They can either be attached. They could either use the same or different neural networks. We're going to have a dictionary of mutations. We're going to have a meter for iterations. We're going to have a field with our current best fit. From our fitness function, we're going to have a sensitivity, which will be a threshold that we're going to need to cross if we're adding a neuron as one of our mutations. And see, if we add a neuron, that's going to change the topology of the entire neural network, right? That's why it's a topology and weight evolving artificial neural network. We'll get into the weights more with the mutations, but anyway, we have a seed for our RNG. We're not using it yet. This actually seems kind of useless. Let's just comment that out for now. We have we have the bulk of our work here in this constructor in terms of actually creating the object. We're going to assign our fitness function, our network, and our mutations. And if our mutations are not null and the dictionary is not empty, we're going to add those mutations to our species mutations dictionary. And then we're going to determine our first best fit by calling our fitness function on our existing network. We have another species constructor just in case we're not going to pass in any mutations. That might be a valid scenario. We actually do have a valid scenario that we'll talk about later, but we